All right, continuing with future value in Chapter 4. Like I showed you earlier, if we go in here and we say equals future value, tab, that gets us in the formula. If you're new to the formula, I would suggest hitting the FX button up here. Come in here and you can do the rate, and it was 10% or 0.10. Number of years, the total number of payment periods, that's 3. And then there was no payments. Present value is negative 100, that's the amount of investment. And we just simply hit 0. You can also go actually in the cell and type in each one of these individually without hitting the FX button, which you can see how that works pretty clearly. So that's future value, very simply. All right. So here it's asking us what is the present value. So the last slide, just to finish up on that, it was future value, and I just showed you how to do that. So now it says, hey, what is the present value of $100 due in 3 years? What is it worth today if the interest rates per year are 10%? So again, there's multiple ways you can do it. I'm going to show you how to do it in Excel. So you can see I've already done it up here, but I will walk you through it as well. All right, so same thing, equals. Instead of future value, we're going to do PV for present value. You're going to tab. The rate's still 10%, 0.10, comma. Still 3 years. Still no payments. It's not an annuity. This is just a single one-time payment. And then the future value is $100, and that's what you're going to receive it in the future, so it's a positive number. So it's negative 75.13. So that's what you would be willing to invest today to get $100 in 3 years at 10%. Alright, and then the slide here shows you how to do that if you need help with that. Alright, so now we're going to talk a little bit about finding the time to double. How long does it take to double your investment? And this just shows it on a timeline, and then you're solving for n. So here again, I'm not going to walk through the formula because you guys can figure that out. This is simple math, but again, you're solving for n, and this says it's going to take 3.8 years to double your investment. So pretty simple if they ask you to do that on the homework. You can also use this formula in Excel to get to the same answer. So if you don't want to do the longhand version, very simply just equal, put in this formula, and go through the steps like I've showed you. Alright, so a lot of times we'll have a lot of information. We'll have the future value or the present value or both of an investment, but we don't know, hey, what is the interest rate of that return? And here's a simple way to find out the interest rate. And you can see, they show it on the timeline. They show you the actual formula. But again, there's a simple way in Excel to do it. Right? So you would use the rate function, put in the 3. There's no payments. It's the present value of -1, future value of 2, and it's going to spit out 0.2599 or 25.9%. So again, just want to show you a quicker way to get to the same answer. All right. So now we're going to talk about annuities, and this is going to be a little more in depth for a while. You have a standard annuity or an ordinary annuity, and that is paid at the end of each year. But then you have an annuity due, which is paid actually at the beginning of each year. So you can see the difference here, right? You have a payment at the end of year 1. Here you would have your first payment before year 1, so at the beginning. So that's the difference between the two. So now they're asking us, what is the future value of a 3-year annuity at $100 and 10% interest? Right, so what is the future value today if we're going to invest 100 here, 100 here, and 100 here at 10%? And it actually is $331. So we'll show you how to get to that. So obviously, you can do longhand math if you'd like, right? Here's the formula. Here's how you get to it. Not going to dwell on that. It's in the PowerPoint if you like spending the time. But there's also a way to do this in Excel, and I will show you that as well. So let's skip over to Excel here. So future value of an annuity, right? So I'm going to say equals future value. So it's very similar to what we did on that. We know the rate is still 10%. We still know it's 3 years. But this time, instead of having the present value, we're going to have our payments of negative 100. And then present value is 0. There we go. $331 is the future value of that annuity. Okay, so hopefully that is very simple and easy to understand. Excuse my instant messages over here. All right, so back to the PowerPoint. There again, this is a very similar situation, but they're saying, okay, what is the present value of this same annuity? We've seen what the future value is. Now what is the present value? Again, I won't belabor the point. You can do the longhand math if you like. That's in the slides, but you can also come in here and do the same type of thing using the present value calculation, inserting the payment right there. 3 years payment of $100 versus the future value. That's going to get the same answer for you. All right. So they are saying now, hey, what do we do differently if it's an annuity due? And if you remember, that just means the payment is at the first of the year versus the second. I can show you real quickly in Excel, and then I'll show you the next slide. The only thing we have to change in our formula is this last selection. And normally we've been leaving it blank because it's going to revert to 0. But if you click in there, you can see that 0 is the end of the period, 1 is the beginning of the period. So if you add a 1, that's going to simply add that in and change that type of annuity. Hit enter, and it's going to get you the answer. Right, and changed it to 364.10. So very simply, it's just adding in that selection at the end here of on the type, right? And that shows you. Let's go back to the PowerPoint. Sorry, the wrong one. So there we go. Future value 364.10 versus the other. And here's your present value. And just changing that from a standard annuity to an annuity due. But again, you can do the math as well, right? They show you how to do it longhand. So whichever way you're more comfortable with it, it helps you. All right, and this shows you how to do that in Excel, which I just showed you as well. You're just changing, adding that 1. So here's the formula. So I love how the PowerPoint actually walks you through the different problems, showing you multiple ways to get to the answer. But then at the end of the day, shows you how to do it in Excel, which is the most likely method that most folks are using. All right, so what is the present value when there's uneven cash flow streams? So in this situation, we can see that it's not the same cash flow each year. You got 100, 300, 300, and negative 50 in year 4. So how would we figure that present value out? So it's a little bit different. And I'll show you what they've got in the slide, and then I'll show you in Excel actually. So basically you have to lay this out and then put this formula in place. So let me show you how that actually works. And I've already done it here. So I've got the metrics that I typed in up here. So I've got year 0, 1, 2, 3, 4. So that's just numbers that I've typed in there. Then I put the numbers in. But that's the hard part, right? Is setting it up. And then simply I just did a formula, which is the net present value, 10% is the rate, and then we're going to take that different payments over the years and include those, right? So let me show you how to do that in real action so it makes sense. So equals net present value. I'm going to tab to get in my calculation. I've got 0.10 for my rate. And then instead of clicking value 1, value 2, value 3, I can simply just click and grab, close the parentheses, and I'm good. 530.09 is my net present value of that annuity with uneven cash flow. So that should be pretty simple as well, not too difficult. Right, moving right along. So now we're going to talk about nominal rates and then periodic rates, and really just the difference between the two. So you'll see nominal rates stated in contracts, quoted by banks, brokers. They're not typically used in calculations. The periods are per year, and that must be given. So examples is an 8% nominal rate. paid quarterly, 8% daily interest. So we'll get into that a little bit more. So the other option is periodic rates. Right? You'll see it described as that formula right there, where M is the number of compounding periods per year. So M equals 4 would be quarterly, 12 would be monthly, 360 or 365 for daily. This is how you're typically calculating interest. So an example here is you've got 8% quarterly. That's going to end up being a 2% rate. Okay, so if that's an 8% nominal rate, but it's a periodic rate of 2% if it's done quarterly. If it's done daily, it's an 8% annual, or 0.02 if it's done on the daily. So that should make sense there. What is the impact of compounding? So will the future value of a lump sum be larger or smaller if we compound more often and we hold the interest rate consistent? So does it matter whether they calculate the interest quarterly, monthly, daily? Does that matter? I think we all know the answer to that. Yes, it matters, right? The future value is going to be larger. It's just like a snowball. Each time you compound that interest, it's going to add on and add on and add on. Now, when you're investing, those additional compounding of the interest is great. You love it. On the flip side, if you're paying for a credit card and they're charging that compound interest more frequently, that is going to hurt you. And that's why a lot of folks get into credit card debt, is that compounding of interest. You may think, oh, well, it's only 15% a year. But it's 15% every time they charge you interest, and then they charge you interest on top of that. So that's where compounding comes into play. So how can we calculate this, right? So here in this question, they're saying we have $100 at 12% nominal rate with semi-annual compounding for 5 years. And again, they walk you through the formula, and you can see how to get to that answer. Another way to look at this, you can do it this way. Future value $100 at 12% nominal rate, 5 years with different compounding. So you can see the different ways and the different dollar amounts. And you can see obviously the highest one is daily. Right? If they're compounding that daily, you're going to see that's going to be the highest amount.